All right, the example I always go back to when I feel like I don't recognize what a logarithm is I always go back to 5 squared is 25. So if you want to just memorize that one back, it might help you get through some of the ones that look more challenging with things like fractions and negatives. So um, So I kind of have this one memorized so that when it's been months and months and I have to do logarithms, I go back to this one because I know 5 squared is 25 and logarithms solve for exponents. I know the base of the exponent is the base of the log. It really helps me. So I got log some square 5 of 25 is 2. And logarithms solve for exponents. I'm gonna write that. Sometimes I just what is this log all about? Logarithms solve for exponents. It seems kind of confusing at first while we do it, but as we get further, really the last day of the chapter, we'll start solving equations that you can't solve without a logarithm. So you have your number one, your base 2, exponent 5 is 32, and then you should always kind of question it. Did the way I write it come out true? And eventually you're going to get comfortable just doing it on your calculator as well. But for now, you should be able to rewrite it in exponential form. And you can check that in your calculator if you want. It is 2 to the 5th, actually 32. So rewriting it in exponential form, 2 to the 5th. This one is 27 to the 1/3 is 3. And that one looks weird to me. Can anybody explain how 27 to the 1/3 would give us a 3? How do we do that? Does anybody remember?
Just it's like what's a cube?
Cube root. It's a cube root. Remember, fraction exponents are cube roots. You bring the 3 down and around. The cube root of 27 is 3. So when a number is getting smaller, but it's not becoming a fraction, we're probably thinking of a root of fraction exponent. You need to think about radical form. So that's how that one works out. All right, number 2, rewrite in log form. All right, so step 1 of writing something in log form is just writing the word log. Log. The base of the exponent is the subscript of the log, 64. Logarithms solve for exponents, so I'll go ahead and put the 1/2 at the end. And then the only number left is 8. Log base 64 of 8 is 1/2. And that's because this is a square root. This is the square root of 64. Anything to the 1/2 is a square root. Okay, number 4. Log. I got a little baby 1/3 down here. I know it's going to equal -3 because logarithms solve for exponents. And then the argument is 27. Any questions on number 4? Rewriting. Today we're actually going to graph logarithms. So understanding the rewritten form is going to be really important. Alright, last 4. Is this 4? No, last 6. Alright, this is what I really didn't get to very much yesterday. So I wanted to make sure we went over it quite a bit. When it says evaluate, what do we do? do we evaluate logarithms? So what I like to do, this is how the book is presenting the questions. How math will present the questions. But when it says evaluate, I like to write equal sign question mark. You know, it doesn't have an equal sign, but I like to put the equal question mark. And then I think to myself, 4 to what power is 256?
Four.
So you got it? It's 4? So it's 4. 4 to the 4th is 256. Log base 8.125. So this time I'm thinking 8. So what power is 0.125? I don't know a whole lot about 0.125. But I told you guys yesterday, I think it's our first period, is that with decimals, I really prefer fractions here. So I really want to think about the fraction form of 0.125. So I'm going to use my calculator. So I'm thinking about the number 8, right? They're usually related. So in my calculator, if I go 1 divided by 8, I get 0.125. I was going to go here for a while. Kind of straightforward. 0.125 is the same as 1 divided by 8. And you don't have all your decimals memorized, that's okay. Use a calculator, do 1 divided by whatever that base is. So I'm going to, instead, I'm going to think 8 to what power is 1/8? And then I remember that negative numbers make fractions. So this answer is -1. 8 to the -1 equals 0.125. 8 to the -1 is 1/8. So think about your decimals as fractions. And this answer is -1. And I'm going to stop now and let you guys work a little bit on your own. You have any questions for us? Why don't you grab one from the bookshelf and just put it back under there? If you could write down for But you don't have to think about it. You can do Let's put it in decimal and we can figure out because if this was in parentheses, then it would equal x minus 1. Yeah, that's left 2, and that's down 1. But I really want to know if you're asking about it. You mean 2 to the y plus 1? Let me just sit down and do how I would, but I wanted you to try it out first. See what you can come up with. So I'll just do it on paper. I have some handy down here. Did you use the same table? Just come out. Right one, left one, or now one. Number 67. It might look familiar. But we have to just leave down. Okay, I'm gonna do y plus 1 equals y raised to the These are my well, we can talk about transformation. So what I did first was I added 1 over here. I got y plus 1. And then I did since I was on software, so that's 2 to y plus 1 equals x. Same table, but every time I plug in I added 1. And that made all my x values 1 higher. That doesn't really shift right. But I'm gonna put on decimals and look at the original and look at this one and we can really compare them again.